Welcome to cseguru. In this session, we will discuss traveling salesman problem using dynamic programming approach. Already, we have discussed one example, how to implement with tabulation method and also simple approach. This is the second example. In both the method, we will implement. The problem is solve the following TSP, which is represented as a graph. So this is the given graph where the cities are represented as P, Q, R, and S. And the distance between various cities are represented as numbers on each of the edge. Okay. So here the direction they have not given. So from P to Q as well as Q to P, the cost is 30. Both ways the cost is 30. Similarly, Q to S and S to Q cost is 10. Likewise, we need to consider. So first step is we need to find the cost adjacency matrix. So here if you are considering in the sense the cost adjacency matrix, always the starting vertex we will consider it as 1 and the next vertex is 2, 3 and 4. Likewise, we will consider and we will fill the cost adjacency matrix. So P will be considered as vertex 1 and Q will be considered as 2, R will be considered as 3 and S will be considered as 4. Okay. So 1 to 1, a vertex to itself, that cycle always it will be 0. So 1 to 2 cost is 30. 1 to 3 cost is 6. 1 to 4 cost is 4. 2 to 1 same cost only 30. And 2 to 3 5. 2 to 4 it is 10. Similarly 3 to 1 6. 3 to 2 5. 3 to 4 it is 20. And 4 to 1 4. 4 to 2 10. 4 to 3 20. So this is the cost adjacency matrix. And with this cost adjacency matrix, we will solve the TSP problem using dynamic programming approach. So what is traveling salesman problem? Traveling salesman problem is nothing but the salesman has to start from one city that will be considered as the source city. So this is 1 we will consider, 2, 3 and 4. Okay, for easy reference. So the salesman has to start from one city and he has to visit all other cities exactly only once. And he has to return back to the starting city. So if we are considering here, the salesman will start from the first city. After visiting the first city, the choice may be 2, 3 or 4. Okay. He may visit 2 or 3 or 4. After visiting 2, what is the remaining cities? 3 and 4. After visiting 3, what is the remaining cities? 2 and 4. After visiting 4, the remaining cities will be 2 and 3. Okay. Next level if we are considering, now he has visited 3 cities and the only remaining city will be here it is 4 and here it is 3 and here if we are considering it is 4 and here it is 2 and here it is 3 and here it is 2. Now if we are considering here, these are all the different choices so that the salesman can choose the path to visit all other cities exactly only once. And after visiting the cities, he has to return back to the starting city. Okay. So that is the meaning. This is nothing but a traveling salesman problem. And here, if you are considering in the sense, we will construct the cost value, that is the cost to travel from one city to another city. We will construct it reverse. So first we will construct this level values and next this level value and this level value and then this one and finally we will get the minimum cost. What is the minimum cost to travel? That path the salesman will choose. Okay. So here if you are considering, keep in mind the cost we will construct in reverse. So case 1 we will construct this cost, the last level cost, and case 2 we will construct the previous level, that is third level. And case 3, we will construct the second level. And case 4, we will construct the first level. Okay. Likewise, we will construct the cost. So, if you are considering the solution, here they have given number of vertices. Here is n is equal to 4. So, here, since the number of vertices is 4, we have to construct 4 levels. That is 4 case values we will construct and in that we will calculate the cost. Case 1, consider S is equal to 5. The meaning is the graph will consist of only 2 cities. He will start from one city and he will visit the other city. And after visiting the other city, there is no other city to be visited. That is the meaning. So modulus S is equal to 0. Okay. So here, and also we need to remember here, always we will use the function to implement dynamic programming approach for a traveling salesman problem. That is G of I comma S is equal to minimum of J belongs to S, C I J. I is the currently visiting city and J is the next visiting city, plus after visiting the jth city, what is the remaining cities to be visited? That is S minus J. Why we are excluding J here? After visiting the jth city, we need to subtract from the vertex set because the salesman has to visit each city exactly only once. That is the meaning. Okay. And this is the function throughout this dynamic programming approach we will implement. Case 1. S is equal to 5. So, G of I comma 5. So I is the starting city. Next, we are going to visit one more city. After visiting that city, no other cities will be there. Okay. So C of ij equal to G of, suppose if the choice is city 2 in the sense 2 comma 5. And after visiting the second city, he has to return back to the first city. Similarly, G of 3 comma 5, that is if the choice is third city in the sense, that is starting from the first city, if he is visiting third city, after he has to return back to the starting city in the sense. Okay. Similarly, for choice is fourth city in the sense, what is the cost? So here if we are considering in the sense, C 2 to 1. 2 to 1 cost is 30. 3 to 1 cost is 6. 4 to 1 cost is 4. Okay. So this is case 1. Next, case 2. So case 2, if you are considering here in the sense, modulus S is equal to 1. Meaning is, start from the first city, visit the next city. After visiting the next city, there is one more city to be visited. That is the meaning. Okay. And the function is same function only. So here, first we need to consider when choice is equal to 2. That is, after visiting the first city, he is currently visiting second city. After visiting the second city, what are all the choices? What are all the choices? That is, the choices may be G of 2 comma 3. That is, after visiting the second city, he can visit city number 3. Otherwise, 2 comma 4. After visiting the second city, choice may be the fourth city. That is the meaning. Okay. So implement this function. That is minimum of J belongs to S. Cij. So I is nothing but 2. And after visiting 2, he has to visit one more city, 3. So C23 plus G of, after visiting the third city, there is no other city to be visited. That's why 3 comma 5. Okay. So C23. 2 to 3 cost is 5 plus G of 3 comma 5. 3 comma 5 value is 6. So he will get 11. For this one, this is minimum of J belongs to S. C to 4. 2 to 4. Currently he is visiting 2 and next he has to visit 4. Okay. Then G of J comma 5. So J is 4 comma 5. 3 to 4. 2 to 4 cost is 10 plus 4 comma 5, the value is 4. So he will get 14. Okay. So when I is equal to 2, suppose when I is equal to 3, what is the choice? After visiting 3, he may visit 2. Okay. If the choice is 3, currently he is visiting in the sense, after visiting 3, he may visit 2. Or after visiting 3, he may visit 4. The same function only we have to implement. The function is minimum of J belongs to S C32 plus G of 2 comma 5. Okay. And for this one, minimum of J belongs to S C34 plus G of 4 comma 5. So 3 to 2 cost us 5 and 2 comma 5 the cost is 30. So here we will get 35 and similarly here 3 to 4 cost us 20 plus 4 comma 5 cost us 4. So he will get 24. Okay. So this is when I is equal to 2. This is when I is equal to 3. Similarly, when I is equal to 4, I will write here when I is equal to 4. T of 4, comma, after visiting fourth city, choice may be 2 or after visiting fourth city, choice may be 3. Okay, the same function we have to implement. That is minimum of J belongs to S, C42 plus G of after visiting second city, there is no other city to be visited. That is the meaning. Okay, so C42 cost is 10 plus 2 comma 5 cost is 30. So we will get cost is 40. Next, G of 4 comma 3. That is minimum of J belongs to S, C 4 3 plus G of after visiting 3, there is no other city to be visited. That is the meaning. So 3 comma 5. And C 4 to 3 cost is 20 plus 3 comma 5 cost is 6. So we will get it as 26. Okay. So this is case 1. Case 1 if we are considering in the sense S is equal to 5. Meaning is there is only one more city to be visited from the starting city. That is the meaning. We will calculate the cost. Similarly, case 2 if we are considering in the sense start from the source city and after visiting the current city, there is one more city to be visited. In that case, what is the cost we have calculated? When I is equal to 2, that is start from the starting city and next if you are visiting I is equal to 2 in the sense what are all the choices. Next if you are visiting 3 in the sense what are all the choices. Next if you are visiting 4 in the sense what are all the choices. So now case 1 and case 2 is over. Next case 3 if you are considering in the sense we need to assume that start from the source city, next visit the current city. After visiting the current city, there are 2 more cities to be visited. In case 2, if you are considering after visiting current city, there is only one more city to be visited. But in case 3, if you are considering after visiting the current city, there is 2 more cities to be visited. Likewise, we need to consider and calculate the cost. Next is case 3. And here if you are considering, this is the case 1 values and case 2 values which is required to implement case 3. And case 3 if you are considering, modulus S is equal to 2. And the function is G of I comma S is equal to minimum of J belongs to S, Cij plus G of J comma S minus sec. We need to subtract this G. And here also we will consider when I is equal to 2 first. So when I is equal to 2, consider G of 2 comma, that is currently he is visiting the second city. After visiting second city, there is 2 more cities to be visited. That is 3 and 4. Okay. So here if we are considering minimum of J belongs to, this is 3 and 4. C2, 3. Suppose he is choosing the city number 3 to be visited in the sense G of 3, comma, after visiting third city, one more city is fourth city. Okay. Otherwise, suppose if he is visiting 2, 4, that is C2 to 4. After visiting second city, choice is fourth city in the sense. After visiting fourth city, he has to visit third city. Okay. That is the meaning. Which one is minimum? We will consider here. So, here if we are considering C23. C23 cost is 5 plus G of 3 comma 4. G of 3 comma 4 cost is 24 comma C24 cost is 10 plus G of 4 comma 3. 4 comma 3 cost is, this one is 26. So here we will get 29, that is minimum. Okay, we have to choose minimum. Okay, minimum of 29 comma 36. Which one is minimum? 29 is minimum. So this value is 29. Okay. Suppose if he is choosing city 3 to be visited when I is equal to 3. G of 3, comma, after visiting third city, there is 2 more cities. That is 2 and 4 to be visited. That is the meaning. Okay. So minimum of J belongs to the cities 2 and 4. C 3, 2 plus, suppose he is currently visiting third city. Next choice is second city to be visited in the sense G of 2, comma 4. Currently he is visiting third city. Next visit second city and then one more city to be visited. Okay. Similarly here C 3, 4. Currently he is visiting third city. Next choice is fourth city in the sense after visiting fourth city there is one more city to be visited, that is 2. So here we are considering minimum of C32 cost is 5 plus G of 2, comma 4. 2, comma 4 cost is 14, comma C3 to 4. 3 to 4 cost is 20 plus G of 4, comma 2. 4, comma 2 cost is 40. So minimum of 19, comma 60. Which one is minimum? 19 is minimum. Okay. Next. Suppose if choice is fourth city in the sense G of 4, comma after visiting fourth city there is 2 more cities to be visited, that is 2 and 3. That is the meaning. Okay. So minimum of J belongs to 2, comma 3. 3, 4, 2. Currently he is visiting fourth city. Next he has to visit second city. After visiting second city, there is one more city to be visited. That is 3. Suppose if choice is after visiting fourth city, choice is third city in the sense C4 3 plus G of after visiting third city, there is one more city to be visited. That is 2. So here we are considering minimum of C4 to 2 cost is 10 plus G of 2, comma 3. G of 2, comma 3 cost is 11, comma C4 to 3 cost is 20 plus G of 3, comma 2. 3 to 2 cost is 35. So which one is minimum? So here we will get minimum of 21, comma 55. Which one is minimum? 21 is minimum. Okay. So here case 3 we are considering when choice is 2. Next you are going to visit the second city in the sense what is the next remaining cities to be visited, that is 3 and 4. Suppose choice is third city. Current city to be visited is third in the sense the remaining cities are 2 and 4. Current city is fourth in the sense remaining cities are 2 and 3. And this is the case. And this is the cost we have calculated. This is case 3. Next, case 4 if we are considering. Here we need to consider modulus S is equal to 3. That is, there are 3 cities to be visited. From the source city, we need to visit 3 cities. That is the mean. So the function is G of 1, comma 2, 3, 4. The starting city is 1. He has to visit 2, 3 and 4. And here he has to subtract the first city. And we need to come back to the first city also. Okay. So the function if we are considering in the sense C12 and C13 and C14. Keep in mind here we are calculating the state space tree in reverse. Okay. So here if we are considering the first level cost we are calculating now. Second level, third level and fourth level cost already we have calculated. C12 if we are considering in this sense C12 plus G of that is 1 to 2 he has to visit. Okay. After visiting the second city, that is current city is second city, he has to visit 3 and 4. That is the meaning. Okay. Suppose C13 if you are considering in the sense that is starting from the source city. After that you are visiting the third city. Next he has to visit 2 more cities, that is 2 and 4. Similarly C14 if we are considering in the sense G of 4, comma after visiting fourth city he has to visit 2 and 3. That is the meaning. Okay. And here so totally we have to take the minimum cost. Which one is minimum? That we will choose here. Okay. So here if we are considering C122 cost is 30 plus G of 2, 3, 4. See, for this we need the reference value from case 3. C12 cost is 30 plus G of 2, 3, 4. Cost is 29. So here we will get 59. Here if we are considering C123 cost is 6 plus G of 3, 2, 4 cost is 19. So here we will get 25. And next C124, if you are considering cost is 4 plus G of 4, 2, 3 cost is 21. Here also we will get 25. So if we are considering here, we have to take the minimum out of this. Both these two parts will give the minimum cost. So the traveling salesman may choose any one from this. So G of 1, starting city is 1, 2, 3, 4. What is the cost? Cost is 25. Minimum cost is 25. And the optimal path, if we are considering in the sense, 1 to 3, 3 to 2, 2 to 4, and 4 to 1. 1 to 3, if we are considering, cost is 6, 3 to 2, cost is 5, 2 to 4, cost is 10, plus 4 to 1, cost is 4. So totally we will get 25. So optimal cost is 25 and the optimal path is this one. Otherwise, one more path is also there. 1 to 4, 4 to 2, 2 to 3 and 3 to 1. So this cost, if we are considering 1 to 4, cost is 4 plus 4 to 2, cost is 10 plus 2 to 3, cost is 5 plus 3 to 1, cost is 6. So this also we will get 25. So any one of the path the salesman can choose to travel. So this is nothing but traveling salesman problem using dynamic programming approach. So these are all the steps we need to follow to implement the dynamic programming approach. In the next session, we will discuss the same example to implement with the simple approach using state space. But exam point of view, if you are considering, this is the method to implement. Okay. For understanding purpose, I will provide the simple approach. Thank you for watching this video.